Now it's your turn to algebraically determine the x-intercept and y-intercept for a given linear equation. Stop this video, take a moment to write out your answers to these problems in your lecture outline packet, and then turn the video back on to check your answers. We know that the x-intercept occurs where a linear function intersects that x-axis. So that x-intercept is going to occur where y equals 0. So to solve it algebraically, we'll take our equation 4x plus 8y equals negative 12 and replace y with 0. So I have 4x plus 8, and instead of y I'm going to put in 0, and that's all equal to negative 12. Now we'll solve for the value of x, so 4x plus 8 times 0 will simplify to 4x. And so now I have the equation 4x equals negative 12. Solving that in my last step, I'll divide each side by 4, and that will give me x equals negative 12. So the x-intercept is the point, negative 12, 0. Again, I've solved for the x value. I know because it's the x-intercept that the y value is 0. Finding the y-intercept, again the y-intercept occurs where this linear equation intersects that y-axis, and x is always 0 when we're on the y-axis. So we'll take the equation 4x plus 8y equals negative 12. We'll replace x with 0, and then we'll solve for y. So we'll have 4 times 0 plus 8y equal to negative 12. That's going to simplify down to 8y equals negative 12. And dividing each side by 8, I'm going to get y equals negative 12 over 8. So this will have to stay in fraction form or be turned into a decimal, but I'll simplify this negative 12 over 8, dividing each of those by 4, I'll get negative 3 halves. So the y-intercept is going to be the point 0, negative 3 halves.